I guess today we are going to discuss about scheduling algorithms. Let us start what is scheduling algorithms. So basically, whenever you are going to consider a processor will be executing the number of tasks. So while executing the number of tasks, so it will be queuing in a job. So there are number of jobs to be executed, so it will be keep it in a queue. So now it goes to the ready queue. So then it has to execute the number of tasks by the CPU from ready queue to CPU. It means CPU is set to be a running queue. So once it has completed its execution, it will be exiting. So otherwise, so it will be goes to the waiting queue. So from waiting queue to it will be it goes to the IO queue. From IO queue to again it goes to the ready queue. So once the other higher priority process has completed its task, so it will be coming to the CPU and exiting the task. So like that, the certain kind of scheduling algorithms are there in order to make your tasks to be executed faster manner. So there are different types of scheduling algorithms. So there are two types. So here we are having a preemptive scheduling algorithm and non-preemptive scheduling algorithm. Preemptive means we will be removing the process forcibly. So other higher priority process will be completing the task, and after that the particular task will be resuming its state. Those particular type of algorithms are called preemptive algorithms. The other type of algorithms are non-preemptive algorithms. So those non-preemptive algorithms will be executed without giving the priority to other tasks. So let us consider the preemptive scheduling algorithm. In preemptive scheduling, the operating system can interrupt a currently running process and allocate the CPU to other process. The scheduler has the authority to force the currently running process to relinquish the CPU before it has completed its execution. This type of scheduling allows for better responsiveness and ensures that no single process can monopolize the CPU for an extended period. Examples of preemptive scheduling algorithms include round-robin priority scheduling algorithms and multi-level scheduling. Preemptive scheduling algorithms are shortest remaining time first, longest remaining time first, round-robin and priority based. Non-preemptive scheduling. It is also known as cooperative or voluntary scheduling. Non-preemptive scheduling allows a process to hold the CPU until it voluntarily releases or it until completes its execution. The operating system has a limited control over the running process, and a process can only lose the CPU when it explicitly yields or completes its execution. Non-preemptive scheduling is simpler to implement but may lead to lower system responsiveness, especially if a long running process is not willing to give up the CPU, so then the problem is arise. Examples of non-preemptive scheduling algorithms include first come, first serve, and shortest job next, also known as shortest job first. Non-preemptive examples are first come, first serve, shortest job first, longest job first, highest response ratio next. So let us consider this scenario. So whenever you are having a ready queue and running queue, so ready queue is a queue which will be all the process will be staying in a queue in order to execute to the CPU. So all process will be staying in a line. So whenever it is going to enter from ready queue to running queue, so the process execution and new process arrival are the two steps it is going to execute. In preemptive scheduling, a process may not necessarily execute complete in one go. Operating system can interrupt the currently running process before it completes its burst time. New processes are allowed to enter the ready queue even if the current process has not completed its execution. So here P1 is going to comes to the ready queue to running queue, and P2 arrives to the ready queue and it has to run the task, and P1 has to enter to the ready queue until P2 completes. So once P2 has completed, P1 enters to the ready queue and again it comes to the running queue. If P1 comes again to ready queue, it means higher priority process may have arrived. Based upon time quantum, decision should be made. Ready queue operations are process can be placed in ready queue and brought back into the running state in the future. Terms we need to remember are arrival time. Arrival time is time taken at which a process enters the ready queue or a state. Burst time, time taken by a process to execute on the CPU. Completion time, process execution time. turnaround time is process completion time minus arrival time. Waiting time is turnaround time minus burst time. Burst time is the time at which process gets first time CPU minus arrival time. So we are going to calculate based upon these particular formulas. So here if you are going to consider the burst time, it depends upon duration, so how much time it is taken by the CPU. Example, if you are going to consider the completion time, if you are going to bank, so you may be standing in a line, so how much time taken by a person, so if he enters in a counter and the particular bank manager is or a bank employee is going to make a seal and complete his task, so how much time he spent on the CPU, so not based upon he has parked his vehicle and entered his bank and completing the task, so based upon that it will be executed. For example, total time inside the bank, so only we are calculating the useful time, how much is the useful time. Waiting time is calculated turnaround time minus burst time. So there are two types of bounds, CPU bound and IO bound. So let us consider the first one, so which is first come first serve. So here we have given the four type of different process. So here we have P1, P2, P3 and P4. So here we have given a table, process number, arrival time, burst time or execution time, completion time, turnaround time, waiting time and response time. Already we have a formula in order to complete the remaining things. So here P1 has given a arrival time, P2 has given arrival time, P3, P4 has given arrival time, and the burst time, the execution time is also given. So we are going to draw a Gantt chart. Based upon the Gantt chart, we are going to calculate completion time, turnaround time, waiting time and response time. So now we are going to draw a Gantt chart. So Gantt chart we are going to draw. So P1 at which time it has arrived, the arrival time is 0. So now here up to what time it is going to execute. So it is going to execute up to 2. So here we have drawn. So left side is the arrival time and the right side is the completion time. So now P2 arrival time is 1 and it has arrived between 0 to 2. So means now P2 is arrival time is 1. So now P1 has taken the time from 0 to 2. So P2 may have arrived the time between 0 to 2. So like that we are going to complete. So the next task to be executed is P2. So now P1 has completed his task. Now P2 has arrived. So the P2 burst time is 2. So P2 may arrived at 1. So even though P1 was busy, so it is going to execute its task. After its completion, P2 has arrived and it has taken time 2. So now 2 is the arrival time of P2 because P1 has occupied the CPU. So now 2 plus 2 is equal to 4. At 4, P2 has completed its execution. So now at P3, so P3 has arrived at time 5. So it means, so here the process will be remaining idle. The process is going to remain the idle. So next P3 has came to execute its task. So at 5, P3 has arrived in order to complete the task. So now it is going to take the time period 3. So now 5 plus 3 which is equal to 8. So likewise P3 has completed its execution at 8. So next at a time between 5 to 8, so which particular process has arrived? So between 5 to 8, so we have a particular process which is arrived P4. So P4 arrival time is 6. Between 5 to 8, 6 has been arrived. So 6 is the time which P4 has been arrived. So it is going to enter the state. So now we are going to calculate the P4. So now P4 has completed the time at 4. So it is going to take the burst time 4. So now 8 plus 4 which is going to be 12. So next we have completed all the process. So now what we are going to do, so completion time. So in order to calculate the completion time, so we are going to take the values of the process from Gantt chart. So this particular chart we are going to make. So which particular part we are taking? Right hand side. So right hand side we are going to calculate so the particular process in order to mark the completion time. So now if you are going to consider the right hand side, P1 has completed at time 2. So now 2 we have marked. So next what we have done? So P2. So where P2 has completed at 4. So now we are going to mark the 4. So next, which process is going to arrive? P3. So P3 is going to complete at 8. So now 8 we have marked. So next, P4. P4 has completed at 12. So right hand side values we have marked. So now we need to calculate the turnaround time. So in order to calculate the turnaround time, we are having a formula that completion time minus arrival time. So what is completion time? 2, 4, 8, 12. So what is the arrival time? 0, 1, 5, 6. So completion time minus arrival time. So we are going to calculate this particular values. So now 2 minus 0 which is 2, 4 minus 1 which is 3, 8 minus 5 which is 3, 12 minus 6 which is 6. So finally we have calculated the turnaround time. So next we need to calculate the waiting time. So in order to calculate the waiting time, so we are having a formula. So turnaround time minus burst time. So we have got the turnaround time. So turnaround time minus burst time we are going to calculate. So now let us calculate the turnaround time minus burst time. So 2 minus 2 which is 0. Next 3 minus 2 which is 1. 3 minus 3 which is 0. 6 minus 4 which is 2. So finally we have calculated. So next we need to calculate the response time. So in order to calculate the response time, so we are going to calculate the time taken by a process got first time CPU. So P1 has got the CPU at time 0. P2 has got the CPU at time 2. P3 got CPU at time 5. P4 got CPU at time 5. So we are going to take the left hand side in order to calculate the response time. So whereas in order to calculate the completion time, we are going to consider the right hand side. So this is the blind note you need to remember. So now let us calculate. So what is the left hand side? So the particular values which is the left hand side is 0. So minus arrival time. So 0 minus 0 which is 0. So next P2. So P2 at left hand side is 2. So 2 minus 1. So which will be 1. So next we calculate the particular P3 at 5. So 5 minus 5 which is 0. So next we calculate P4. So P4 is 8. So 8 minus 6 which is 2. So in this manner we are going to calculate the particular values for first come first serve. So now we need to calculate the average turnaround time and average waiting time, and we are going to calculate the average turnaround time. So total values divided by total number of process. So 2 plus 3 plus 3 plus 6. So now which is 14. So 14 by 4. So which is 3.5. So next average waiting time. So total 3. So 3 divided by 4. So which is 0.75. So we have calculated the average waiting time. So next one is shortest job first. So here we are going to calculate. So based upon which particular job is we are going to allow the first. So based upon short job we are going to allow it to the enter into the CPU, and we are going to make to calculate. So its mode is non-preemptive. So no interrupt while the execution is going on. So no interrupt is made while execution is going on. So in this manner, we are going to calculate the shortest job first. So now let us consider the scenario. So the P1 has arrived at time 1. So arrival time is 1. So arrival time is 1. It means from 0 to 1, the process remains idle. The process is idle. So next, we are going to calculate based upon the burst time. So based upon the burst time, so we are going to calculate at which time the particular process has arrived. So now here we are going to calculate at time 1, so which particular process has arrived. So at time 1, so two particular process has arrived. So which are P1 and P2, P3, P1 and P3. So even though P1 and P3 has arrived, so which particular time is less? P3 is having a less time. Based upon the burst time, we are going to allow the process P3 to enter inside the chart. So now 1 to 3, it has taken the execution. So it has taken 2 seconds of time in order to complete. 2 seconds or 2 milliseconds. So now are nanoseconds. So 1 to 1 plus 2, which will be 3. So next we are going to allow the P1, so which is having the burst time 3. So now it will be becoming, so 3 plus burst time is 3, 6. Based upon the burst time, we are going to allow each and every process. So now P1 has completed and P3 has completed its task. So the remaining tasks are P2 and P4. So among P2 and P4, so even both are having the values of burst time same, but based upon the arrival time, we are going to allow P2 in order to enter the CPU. So we have allowed the P2 enter into the CPU. So now P2 we have calculated. So 6 plus 4, which will be 10 on the right hand side. So next next we have completed the three particular process P1, P2 and P3. The last one is P4. So we are going to allow P4 in order to execute the task. So P2 has completed at time 10. So now P4 burst time is 4. 10 plus 4, so which will be 14. So next we have to calculate the completion time. So the completion time, what we are taking, we are going to take the right hand side. So what is P1? So P1 right hand side is 6. So we have entered the completion time is 6. So next P2. So what is P2 right hand side? 10. So P2 right hand side is 10. We have made 10. So next P3. P3 right hand side is 3 and we have marked 3. P4 right hand side is 14 and the value will be 14. So next, what we need to calculate? We need to calculate the turnaround time. Turnaround time is given by the formula completion time minus arrival time. So what is the completion time? So 6, 4, 3, 14 minus arrival time 1, 2, 1, 4. So we are going to calculate the arrival time. So 6 minus 1, 5, 10 minus 2, 8, 3 minus 1, 2, 14 minus 4, 10. So next we need to calculate the waiting time. So the waiting time is calculated by turnaround time minus burst time. So we are having a turnaround time minus burst time. We are going to calculate the waiting time. So now let us calculate each and every one. So now 5 minus 3, which is 2. Next 8 minus 4, which is 4. 2 minus 1, 2 minus 2, which is 0. 10 minus 4, which is 6. So we have calculated the burst time. So next we need to calculate the response time. So in order to calculate the response time, the rule is we are going to take the left hand side minus arrival time. So for P1, so 3 is the particular left hand side. So minus 1, so which is 2. So next we calculate for another one. So we have got the value 4. So it means, so the particular left hand side of our P2 is 6. So 6 minus 2, arrival time is 2, which is 4. Similarly, we are calculating P3. P3 left hand side is 1. So 1 minus 1 is 0. So next P4. So P4 left hand side is 10. 10 minus 4 which is 6. So we have calculated the response time. So now we need to calculate the average turnaround time and waiting time. Average turnaround time is total value is 25. So 25 divided by 4 which is 6.25. So now average waiting time, so it is 12. So 12 divided by total number of processes is 4 which is 3. So next one is shortest remaining time first. So it is also known as SJF with preemption. So preemption means we are going to interrupt the process in between. So the criteria is the burst time when there is a completion among the process. Its mode is preemptive. You will be removing the process in between. So now based upon number of process has arrived at the point of time we need to check. So allow the process based upon the burst time and arrival time. So we are going to check burst time and as well as a arrival time. We are going to allow the process. So let us consider a ready queue, so which we are going to allow the process. So ready queue is having a process P1. So P1 at we are going to allow the process for 1 unit of time. So how many number of units of time? So allow each process to execute 1 unit of time. So here we are going to allow each process for complete 1 unit of time. So now from ready queue, process P1 has arrived. So now if you are going to consider, there are 2 queues. So this particular queue is called ready queue and this particular queue is called running queue. So now P1 has arrived at time 0. So it will be executing at one unit of time. So next what we are doing? So next we are going to allow the next particular process P2. P2 will also allow 1 unit of time. So next we are going to allow the another process P3. P3. So while we are allowing another process P3, so we are going to check. So how P1, P2, P3. So even P3 has to arrive at a time 2. P2 is having less burst time. So we are going to make the comparison. So here P1, P2, P3, P4. So now if you are going to calculate P1, P2, P3, so now P2 has arrived at time 1. So P2 has arrived at time 1. So now P3. So now P3 we are going to calculate. So we are going, but P2 is having a lesser burst time. P2 has completed the burst time. So it has one more time it need to be executed. So what time it has arrived? So between 1 to 2. So based upon the burst time. So P3 is burst time is greater than P2 burst time. So we have allowed the one more time to execute. So next. So we are going to compare the P2 burst time. So now P2 has completed its execution. So P2 has remained. So P2 will be executed 1, 2 and 3 times. So it has completed its 3 execution. So now we compare the each and every process arrival time and as well as a burst time. So next P3. So now P3 has to arrive. So P3 burst time is 4. So now which particular process we need to allow? So at time 4, so here P4 has arrived at time 4. So 4, but its burst time is only 1 unit. So P4 has completed its execution. P4 has completed its execution. So what are all the units we are having? P1, which is having a burst time of 4, P3, which is having a burst time of 4. So these two things we need to execute. So now we are going to allow the P1 in order to execute 4 number of units at once, because so both are having a equal time. So there is no need to have a competition between the P3 and P1. So what we have done, compare P1 and P3. P2 and P4 has completed the execution. P3 has arrived both P1 and P4 has same burst time. Based upon the arrival time, we have selected P1 in order to execute the task for 4 units of time. So P1 has completed at 9. So later on, we are going to allow the next process P3. So we are going to allow P1 to execute 4 units of time. So next, we are going to allow the P3. So now P3 has completed its task at time 13. At time 13, P3 has completed its task. So now we are going to calculate the completion time. So completion time, in order to calculate, we are going to calculate the right hand side. So P1, at which time it has completed. So P1 has completed at 9. So next P2. So P2 has completed at 4. Next P3. P3 has completed at 13. So next P4. P4 has completed at 5. So now, so the result will be 9, 4, 13, 5. So 9, 4, 13, 5. So because we are calculating the right hand side. So next we are going to calculate the turnaround time. So now in order to calculate the turnaround time, we are having a formula completion time minus arrival time. So what is the completion time? So completion time we are having minus arrival time. So 9 minus 0 which is 9, 4 minus 1 which is 3. So next 13 minus 2 which is 11, 5 minus 4 which is 1. So now we need to calculate the waiting time. So in order to calculate the waiting time, we are having a formula waiting time equal to turnaround time minus burst time. So we are going to calculate the waiting time by turnaround time minus burst time. So here we are taking the 5, 3, 4, 1 as a burst time. So 9 minus 5 which is a 4. So next we are going to calculate 3, 3 minus, so 3 minus 3, so which will be, okay, so here we have done another. So here we are going to calculate, so 3 minus 3, here it is 0. So next here 13 minus 2 which is 11, so 5 minus 1 which is 4. So we have calculated the waiting time. So we have got the waiting time. So here we have got the response time. So response time we are going to calculate LHS minus arrival time. So we are going to calculate the LHS, so minus arrival time. So left hand side minus arrival time we are going to calculate. So finally we are going to get the value. So P1 at time 0, 0 minus 0 which is 0. So next P2 has arrived at 1. So 1 minus 1 which is also 0. So next P3. So P3 has arrived at 9. So 9 minus 2 which is 7. So next P4 has arrived at 4. 4 minus 4 which is 0. So in this manner we are going to calculate the response time. So finally we are going to calculate the average turnaround time, average waiting time and average response time in this manner. So here if you are going to see the average turnaround time, so which will be changed. So here turnaround time we are going to waiting time. So waiting time is, so 2. So we have got the correct values 4270. So now here we are going to calculate 9 plus 4 11. So 11 divided by 4 2.75, 7 divided by 4 1.75. Average turnaround time 24 divided by 6. So which will be 6. So we have completed the shortest remaining time first. The next one is round robin. So this is one of the popular technique. So here in this round robin, so we are going to create a time quantum. So in the problem they will be mentioning the time quantum is 2. Its mode is preemptive. So first what we need to check is how many process has arrived. So here we are going to take the two queues, ready queue and running queue. Based upon that we are going to calculate. So now we have taken the two particular process, ready queue and running queue. So now here the criteria is time quantum. So based upon the time quantum, so in that, in respect to of burst time, allow the process to execute on CPU and come back to the ready queue. So mode is preemptive. We take two queues, ready queue and running queue. So now here P1 is goes to the ready queue to running queue and P2 arrives. So at that time P1 will be coming back to the ready queue. So here we are going to see, so what is ready queue and running queue. Here the ready queue is RAM. The running queue means a CPU, so which a process will be running in the process control block. So instead of terminating the process, we are going to allow the process to resume its state. So this particular concept is called context switching. So switching particular process to background. So next bringing the process to the foreground to run on CPU. So like that we are going to calculate the particular round robin method. So P1 has arrived and now we have taken a two queues. So first queue is ready queue and another one is running queue. So now here P1 has arrived at a time 0. So at time 0 P1 has arrived. So now, so here we are going to consider P1 is in ready queue. So now we are going to bring the particular P1 into the running queue because no other process are ready at that point of time. So now here time quantum is 2. So because of that reason, so we are going to allow the particular process to allow 0 to 2. So now 5 minus 2, which will be 3. So next from 0 to 2, so between 0 to 2, which process has arrived? So now P1 and P2 has arrived. So because P4 has arrived at time 3, so no process has arrived. So put P2 and P3 into the ready queue. So put P2 and P3 to ready queue. So now later we are going to put P1 into the running queue. So we are going to put the P1 into the running queue. So because first put the particular process which has arrived into ready queue, later on which particular process to be resumed next into the running queue. So likewise we are going to execute two particular time quantum for each and every process. So now P1 needs to resume state, its time quantum is 2. So now we are going to give the 3, so which is remaining time. So now we have brought the process P2. So between 2 to 4, which process has arrived? Between 2 to 4, which process has arrived? So between 2 to 4, the process P3 and P4 has arrived. So but already P2, P3 is in ready queue. So now at point of time, so P4 and P5 has arrived at 4. So now what we are doing? So P2 is in execution state. So now what we need to bring? So we need to bring the P4, P5 into the ready queue. So now bring the P4, P5 into the ready queue. So then what we need to do? So we need to put, so the particular process which is running. So P2 is already running. So it has not completed its state. So put the particular process P2 into the ready queue. So now we have put the process P2 into the ready queue. So next process will be executed P3. So now P3 will be executed and so which is 1. So now P3 has completed its execution. So P2 has completed its execution. It will be removed. So next. So we are going to bring the P3. So later on, so P1 has to be executed one more time. So now P3 has completed and P4 need to be executed. So now before P4, P1 is has to be executed one more time. So now we are going to allow P1. So it has to resume the state and it enters into the running queue. It completes the task of time quantum 2. So P1 will be executed at 2 point of time. So and again it enters to the running queue to ready queue. So now where P1 has to enter, running queue to ready queue it has to enter. So now P4 has entered. So next we are going to bring the P4. So P4 is having only 2. So now P4 will be completed its execution. So at 2. So now P4 has completed its execution completely. So now P3, P4 has completed its complete execution. Now we are going to bring P5. So P5 will be allowed to execute at a time quantum 2. So now P5 has executed time quantum 2. So next we are going to allow the P2. So now here P5 enters into the running queue and executes time quantum of 2. P5 goes ready to the state. So now P5 will be executed. Next we need to execute the P2, P1 and P5 by 1. So because P1 is having 1, P2 is having 1 and P5 is having 1. So we need to execute all the things one point of time. So now P2 has executed its task. So it has completed its task. So next P1 has to execute 1 point and finally P5 will be executed its task. So totally all the tasks are completed. So now what we need to calculate? We need to calculate the completion time. So what we are taking? We need to take the right hand side for completion time. So P1 has arrived. So at what time P1 has completed? So P1 has completed at time 12. At what time P2 has completed? P2 has completed at point 11. So next P3. P3 has completed where? At point 4. So and P4. So where P4 has completed? At 9. So next P5, where P5 has completed? At 14. So let us mark the particular completion time. 13. So P1 has completed at 13. So next P2 has completed at time 12. We are taking right hand side. P3 has completed at 5 and P4 has completed at 9 and P5 we have completed at time 14. So next turnaround time. So turnaround time we are going to calculate based upon the completion time minus arrival time. So 13 minus 0 which is 0. So next 12 minus 1 which is 11. So next 5 minus 2 which is 3. So next 9 minus 3 which is 6. So next 14 minus 4 which is 10. So next we need to calculate the waiting time. So waiting time will be calculated turnaround time minus burst time. Already we have got the turnaround time. So burst time is the value which is previously assigned. So here we are going to calculate turnaround time 13 minus 5, 11 minus 3, 3 minus 1, 6 minus 2, 10 minus 3. So like that we are going to calculate the waiting time. So 8, 9, 2, 4 and 7. So next we need to calculate the response time. Response time is CPU first arrived minus arrival time. So we are calculating left hand side values. So P1 has arrived at a time 0, P2 has arrived at a time 2, so P3 has arrived at a time 4, P4 has arrived at a time 7, P5 has arrived at time 9. So minus arrival time. So we are going to calculate this one. So now here 0 minus 0 which is 0. Next P2 2 minus 1 which is 1. So next P3. So P3 is 4, 4 minus 2 which is 2. P4 which is 7, 7 minus 3 which is 4 and P5 which is 9. So 9 minus 4. So at first time 9 has came. So here we have calculated 9. So 9 minus 4 which is 5. So at which particular first time it has arrived. So that one we are going to calculate. So finally we are going to calculate the average turnaround time. So we are going to compute this particular total in order to make the average. So final divided by 5. Next waiting time total divided by 5. So finally we are going to get the average turnaround time 43 by 5 which is 8.6 and average waiting time which is 5.8 per unit. So if you like this video, please like, share and subscribe my channel. Thanks for watching.